Time for an independent samples t-test. With a paired samples t-test, we're comparing the same people on two different measures. With an independent samples t-test, we're comparing two groups of people on the same measure. In this example, we're looking at a study conducted in which it was compared We're looking at a study that was conducted in which job candidates were being evaluated either based on an audio in which you heard them talk or a transcript in which you just read what they said. Now, different people heard or read about the job candidates, and these were held consistent across participants. So it wasn't like they were looking at different candidates in the audio and transcript. It was the same candidates saying the same things. The difference is whether there was listening or reading involved. So our condition here is whether the participants were in the audio condition or the transcripts condition. And you can see here that it is labeled, but if you click on this, we see zeros and ones, and back to labeled again. That's up here with the 1 and the A with the arrows. Recall that in order to conduct these tests, the condition does need to be dummy coded as numbers. So if it were not indicated with numbers as it is here with ones and zeros, we would not be able to do the test. Now, the independent samples t-test, we're going to compare condition on the perceived intellect of the candidate. So we're going to analyze, compare means and proportions, independent samples t-tests. Our grouping variable is condition. That's the audio and the transcript condition. Now we need to define our groups. We know that our groups are group 1 and group 0. So we're just going to have group 1 be 0 and group 2 be 1 so that SPSS knows which groups to compare. And then for the test variable, we're going to intel for the, intellect. So we're going to go over here to intellect and indicate that. And then we're going to click OK. And we can see up here, we have a table with descriptive statistics. We see that the two conditions are fairly close, but not exactly identical. So there are 18 and 21 participants, with meaning that there would be a total of 39 participants. And that these are the means. And just looking at the means and the standard deviations, you can tell that the difference is about 2, give or take, slightly less than 2 between the two conditions, which is, about a standard deviation, a little more than a standard deviation. So we have a full standard deviations difference, which is a pretty large effect. So it's not surprising when we're just going to assume equal variances for this part. When we look at the t-test, it is pretty sizable, -3.526. And then we see that the p-value is highly significant. So we can also notice the mean difference here is quite notable. As I said before, it was close to 2. This is the exact mean difference. And when we look at the lower and upper 95% confidence interval, we can see that they do not encompass 0. They're on the same side of 0. They're both negative. Having the confidence interval of the difference not contain 0 is a sign that it will be significant. Now let's go back to this whole equal variance is assumed. We're concerned about what's known as homogeneity of variance, which means, do these two groups have similar variability based on the variance, which is the square of the standard deviation. So we're going to go to Analyze, Compare Means and Proportion, Independent Samples t-test. Now we're going to click on that homogeneity of variance test and click OK. And what we can see here when we're looking at the homogeneity of variances, what we're looking to see is if the variances are significantly different. Now we can see here that for this test of 0.35, that is well above a conventional significance level of 0.05. So based on that, we're going to say that they are not different. This is one of the few times in statistics where we can say if it's not a significant p-value, we can assume equality. Now, is it really equal? No, but it's not different enough where we have to adjust our t-tests. We can assume equal variances, which means that we would follow the equal variances assumed in the top row of this column and report these findings. If Levine's test were significant below the 0.05 mark, then we would not assume equal variances and report the statistics in the second row. Now you can see that in both circumstances, they're statistically significant different. It's a pretty robust effect. But you can tell that the t-value is slightly lower, and that's because more degrees of freedom are needed in order to calculate the t-value when the equal variances are not assumed. You may notice that the degrees of freedom here are 37, and the sample size is 39. When we did paired samples t-test and one sample t-test, we only lost 1 degree of freedom. The reason why we lose 2 degrees of freedom is because we're dealing with 2 different groups involved in the testing, and each group loses a degree of freedom. So then we have a total of 37 when equal variances are assumed. Now let's make some bar graphs. We'll go to Graph, Bar, and we're looking at groups of cases. In this case, we're looking at one group of participants that was in the transcript condition and another group of participants in the audio condition. We're not looking at separate variables because we're only interested in one variable, and that is perceived intellect of the job candidate. Let's click Define. We're going to do Other Statistic, Mean, and we're going to click on Intellect for our variable. This is the dependent variable, goes in here. That's what we want represented in the bars. Our category access is condition. And for options, we want to display error bars and change this so it shows 1 error bar, just because that tends to be standard in statistical reporting. And then click OK. You can tell from this graph that the error bars are far from overlapping, which is not surprising considering that they are statistically significant. And you see that it's noted here what the error bars are. That's important because even though generally that's what error bars are, is plus or minus 1 standard error, it could be, for example, confidence intervals or 2 standard errors or other metrics that are involved. So it is really important to report that so that you are being honest and transparent and clear in what you found.